Circular motion question 4. A fairground big wheel ride takes 12 seconds to complete one rotation. The passengers travel at a speed of 2.1 meters per second. Calculate the radius of the wheel. Well, for this we can use speed is equal to distance over time. The distance in this case is the circumference of the wheel, 2 pi r. The time is the time period t. We can rearrange this as the radius is equal to the speed multiplied by the time period over 2 pi. Putting in the figures, 2.1 meters per second for the speed, the time period was 12 seconds, gives a radius of 4.0 meters. Calculate the centripetal force on a child of mass 55 kilograms travelling on the ride. Well, for this we can use centripetal force is equal to mass times speed squared over radius. Putting in the figures gives a force of 60.6 newtons. Draw a free body force diagram for the child when at point B, labelling all the forces. Well, we can simply draw the child as a circle. There will be the weight acting down, the reaction force due to the seat on the ride acting up, and the centripetal force acting towards the centre of the circle. Explain why two of the forces are equal in magnitude at point B. Well, the child is moving with a constant vertical velocity at this point, so there must be zero vertical resultant force, meaning the weight must be the same magnitude as the reaction force. One of the forces changes magnitude as the child moves from B to A. State the force, whether it increases or decreases, and give an explanation. Well, at point B, all the motion is directly downwards. As we get to point A, we move to a situation where all the motion is horizontal. So the vertical velocity of the rider will be reducing as they go from B at a maximum to A at zero vertical velocity. Therefore the reaction force must increase as the downwards vertical velocity is reducing, which is effectively a deceleration, which requires an upwards resultant force.